حياكم الله. طبعا نتكلم اليوم عن نظام الايبوت سيستم، وهو المدخل الرئيسي لعالم الابتكار الحديث في عالم التكنولوجيا. طبعا to start with, I would like to introduce the main parts of the ebot system. Ebot system has three parts. The first part is the software side, software side, which is really big and has a lot of potential. You could do a lot of things with the software side. The software side has three platforms. You could have it on the PC, okay, which could run on Mac, could run on Linux, and could run on Windows. That's the PC side. Also, you can run it on your mobile, an Android version or iPhone version. So this is the software side. It's huge and has a lot of potential, and it's the main core of the overall system. The second stage is the hardware. The microcontroller unit, which is this one, and the electronics that comes with it. The electronics and the system could be covered with the plastic, in case if we want to use it in a kit like this to build something, okay, or could be just the board like this if we want to use it as a professional users. Okay, this is ebot 4, it's coming in 2 months, and this is ebot 8. The difference between ebot 8 and ebot 4 is obvious. It's the size and the number of inputs and outputs pins, where here you have 8 inputs and 8 outputs and 2 DC motors. We're gonna explain this later. Okay, with ebot 4, at the back side you have 4 inputs, 4 outputs, and 2 DC motors. Also, you have the built-in Bluetooth and built-in accelerometer, and also a built-in small RGB LEDs. Let me see if I can run it. Sorry, connection is bad here, but we'll run it. 2 buttons, and you have a buzzer built in. So this has more potential and it's more powerful than this one. Also, this has more pins than this one. Okay. The third platform is the plastic bricks. Okay, and we have a lot of plastic bricks. Each plastic brick has a snapping mechanism where you don't have to have small parts to connect them together. You just go like this and then it snaps. Okay, and the snapping mechanism and the plastic bricks, they were meant for a fast prototyping solution. For example, if you have a class that runs for 45 minutes, what you need is to have those to build like a structure. You don't have small pins where it's you have the chalking the chalking hazard for the kids. They don't chalk in it, they don't eat it. It's big bricks, and if you find a brick laying, you know that you can't connect it to anything. Anyhow, if you can bring the gears and stuff like that, so I can show them. There is many types of bricks, as we're going to show you. Well, and the whole purpose of the plastic bricks is to build a system, and this is the ultimate goal of the ebot system. The ebot system teaches people how to bring their ideas into life, and by doing a system. Okay, so it's doing a system. We have the gears, we have the wheels, and we have a lot of plastic bricks to build that. Okay, finally we will introduce the curriculums, which is the educational platform that joins all the skills together by a way of a story. So it's, for example, this is a sample of it. It starts with a topic, then it goes into a story, and then from the story the kids will understand a concept, okay, and then from the concept they will start building a device, a solution, an innovation, something that brings their ideas, their solution to life. They will use those kits and the software, okay, to solve the problem. So this is it. What I needed to do now, the first thing to start with, I want you to go to the website ebots.cc. Okay, so it's this ebots.cc, and go to downloads. Okay, and then if you're using a Windows, please download Windows new release, this one. Okay, once you get this downloaded, you will have the software. This is the software that we will be using. The software is based on Blockly from Google. So Google, they handed us the visual platform of our C++ programming. Let me go by explaining some of the software potential before we end up this brief session about the ebot system. Okay, well, here you have your inputs, all of your nodes, your inputs, okay, your outputs, and your inputs and outputs are basically models, electronic models that you can plug in. So they're like plug and play, okay, models with wires. They could be like this, as for the professional people, it's obvious it's a button, or it could be like this with a plastic casing that snaps directly to the blocks that or the structure that you built. So we have an inputs, we have outputs, we have flow that controls the flow of the program, we have the logic, we have the variables, we have the advanced node or the advanced tab, we have the media if you want to run media, and also we have our own custom nodes. In the software you can always build a node. What I mean by that, imagine that you have a special sensor. Let's take for example flux sensor, that you found a flux sensor or a pressure sensor, and you want to create a node for that, so you don't have to program it, and you want to share it to people. You want people to be able to understand and use your node. So you can always create your own node and send it to people and share it so the people can use it. Okay, let's see how those could be used. For example, if I want to have a button, okay, and when the button is pressed, okay, when the button is pressed, the button I will connect to A0 or A1. It depends on the pins configuration here, so where I connect it. Okay, I want something to happen. Let's say I want the LCD that I connected to A1, for example, say hi Ahmed. Okay, so as you can see, when I did this code, when I did this, okay, the programming language, the C++ programming, let me make it bigger, sorry. The C++ code has been generated for me, so I don't have to write all of this, but I need to understand how this is generated, and we could teach kids step by step how they can program and how can they understand the C++ program. Okay, and then if I have my board connected, you will see ebot 8 connected. If it's ebot 4, you will see ebot 4 connected, and then you download. Okay, once you download, you will see the LEDs here start flickering, which means it's downloading. Now the program is here. You don't have to connect it, but you need to power your system. You don't have to connect it. The program is permanently embedded in your controller here. Okay, You have also set of examples. If you want to go to examples, let's see the blinking LED example. So you could teach people how to start with an LED, what is the setup, how to include the library, what is the pin mode, pin number 8, it's an output. Those are for the engineering courses. We'll talk about them later. Okay, so this is a simple program. You have here debug, or we changed it actually in the new release to input reading. Basically what this does, it you can select an input. Let's say, do we have an input?
Button maybe?
Yeah, but or any, just bring me any analog read button. Okay, so let's say I want to connect my button, a button, to input 0. So what I want to see, how would this act here before I start programming. So after selecting the pin, selecting the type of sensor, I can see here in the screen, okay, see, when I press, the value goes down. Okay, so I can see what does this sensor see. I can also stop it. Let me see, I have the light sensor. I'm going to connect the light sensor to pin number 7. Okay, pin number 7. So I go to pin number 7, select pin number 7, go to the light sensor, and then debug. Okay, now I will see how the light sensor acts when the light changing according to the environment. Okay, so now the reading is around 500 something. When I close, when I cover it, it goes low. Okay, this is the light now. Okay, it goes low. So input reading is very important to read and understand and see what my sensor sees before I start programming. Okay, the serial monitor is it's a screen that shows you what data did you send back through the USB. So sometime when something happened, you want the controller to tell you something, okay, and this something goes through your USB to the screen. You have the serial monitor screen. Okay. Also we have the live control. What does the live control, do we have RGB LED? Okay. Live control basically does a live control. So whatever you do here, it reflects automatically to the controller here, instead of programming every time. So let's do an example. Let's start. Okay, so now the program is uploading a firmware here, and pin number 0 is an on-off. Okay, so I want it to be high and like this, high, low, high, low. So whatever I do in the system here reflects directly. You could add a servo motor. Let me do that. Okay, that's the number. Okay, this is a servo motor. It's a motor that you could change the angle of. Let's see if I have the head for it. I will do a very simple demonstration now. Okay, so it's connected to pin 1 and it's a servo motor. Okay, so this won't happen again. Okay, so it's 0 now. Let's move it -degrees, and let's go to positive degrees. Okay, and this goes high. Okay, and this goes again low. And I can create a state, like for example this is state number 1, okay, and when I change this, or let's go to minus 90, okay, all the way here, and this is low, okay, so I will set this as another state, okay, so sorry, this state should be positive 90, okay, and it's high here. So this state, so state number 1, state number 2, and I can send all stated and loop them. I want them to do 2 states now and 2 times, and the delay between each state is 1 second. See that? Okay, so this is basically what does the live control. What does the live control do? Okay, we'll talk about it later. You could add a frequency, you could add an RGB, where you can select the color. You could do a lot of things. Okay, so this is it. Let's go to the next one. No. The data lab. The data lab takes a data from a sensor and shows you either a gauge on a gauge level or a graph level. So this is connected to pin 0 again, the same sensor, and this is used a lot in the science classes where students would know or would use this to test the temperature sensor, the light sensor, the humidity sensor, a lot of sensors. Let's go to the next one, which is ebot Blockly. This is to program your mobile, to program your ebot system, so it could take commands from your mobile. So if you want to program from your mobile, you always go here, ebot Blockly, and then you set up your board so it can listen to the mobile, and then you can connect your mobile directly and program it directly. Okay, then we have the node maker, and the node maker, it's a very advanced level where you use it to create a node. And then you have the connection guide. Let me show you if I do a simple connection like a button, okay, and output like a buzzer or something. Okay, when I go to the connection guide, I will see that my A0, according to what I did, is connected to A0, the button, and the buzzer is connected to D0. This will be very, very useful when your program goes big, okay, and you forgot where is which and what things are connected in different ways. Okay, you have your examples here, a lot of examples that you could use. Also, you could also jump to the C++ code and start typing your own code. Don't worry about that. Don't worry, because if you compile and it's wrong, he will tell you that this is wrong. You need to change it. Okay, and if you all want to go back to the original code, you can change anything here, and everything is reset. Let's say that I want to change something here that is correct. It's real programming. Okay, I want to do this as 500. I want to do this as 1. I want to do the frequency as 5011, for example. Okay, and compile. It will compile correctly. It will take whatever C++ code that you write here. So this is it. I think this is a quick overview about the program, and I will see you in the next lesson.